Hi, I am Samyak Kannavar and here is my game Chem Rea, which stands for chemical reactions. In this video, I will introduce my game, give a demo, talk about how the game can be extended, and show some code samples. This game is meant to teach high school students, preferably enrolled in a chemistry class, about reaction prediction, or predicting the products of a chemical reaction given the reactants. Now let me show you my game. Here are the directions of the game. Initially, my game required the player to type in the products. However, following my mentor Mrs. Gupta's advice, I changed the game so that now the player has to rearrange the atoms in reactant molecules to form products by dragging them around, like this. Now let's play the game. The player can add more reactants by pressing the add buttons. Then they can drag them around to form products. Only one correct product molecule is needed to get the correct answer. Excess atoms should be left as reactants. If the answer is wrong, the reason why the answer is wrong is displayed here in the text area. A correct answer in the first attempt earns 10 points, and a correct answer after at least one wrong attempt earns 5 points. One of my evaluators had formed the correct products but was left with an extra atom and was unsure of what to do. Thus, I decided to write the instructions: you need only one correct product molecule, and you can leave excess atoms as reactants on the game panel. Currently, this game contains only 2 levels. More levels can however be added, and the difficulty can be increased by providing more complicated reactants like polyatomic ions, or reactants whose products are harder to predict because there are more than one solutions that seem logical but only one of them is the correct answer. Now here are some samples of my code. The game stores different atoms as objects of the class chemical in an array of objects of class chemical. I have used an array so that similar operations can be performed on each of the objects. For loops are used to do so. For example, for loops are used here to call the methods testMultiple and testProduct for each object in the array that represents the respective atom and is on the screen. If-else blocks are used to decide here whether the right products are present or not. Thus, if the player does not form the correct products, the answer is declared wrong and the message "No correct products are present" is printed. Here I have used border layout for arranging the panels in the main game panel. The class MyMath contains static methods that use math.random and math.squareRoot. The method random is used to create a random integer in the given range and start value, instead of the 0 to 0.999 of math.random. This will be used to randomize the reactants up to a certain extent. The two distance methods are used to calculate distances using math.squareRoot and are used in the game to determine which atoms overlap. Next, we have an example of inheritance. The class DragChemical1 is extending the class JPanel, which shows inheritance, where JPanel is the superclass and DragChemical1 is the subclass. As a result, DragChemical1 can use methods like setBackground, which are defined in its superclasses. Then, we have an example of mouse methods from MouseListener and MouseMotionListener. These are used to drag the atoms around. Lastly, we have an example of FileIO. The method questionScanner initializes a scanner to a particular file. The name of the file can be passed as a parameter. FileIO is used in the game to determine the reactants for the different levels and in printing out mistakes or reasons why an attempt was unsuccessful. I would like to thank my teacher Mr. Mueller, mentor Mrs. Gupta, and evaluator Sanjana Shah and Hannah Khan. That's all I have. Thanks for listening.